Hello everyone, myself S. Vigneshwari, Assistant Professor in the Department of Electronics and Communication Engineering from SNS College of Technology. So today we are going to discuss about tunnel diode under the subject Basic Electrical and Electronic Circuits, and this comes under the unit Special Semiconductor Devices. So unlike conventional diode, the device operates on a completely different principle called quantum mechanical tunneling, which allows it to work at extremely high speeds. So by the end of this session, you will be able to understand why tunnel diodes are needed, their construction, working principle, VI characteristics, and negative resistance, finally with the application. So first, why do we need a tunnel diode? So let's begin with a simple question. So why do we need tunnel diode when we already have a normal PN junction diode? Well, conventional diode work well for many applications, but they have a limitation. They are too slow at very high frequencies. In modern electronics, especially in microwave circuits, radar systems, high-speed communication, we need devices that respond extremely fast. So this is where tunnel diode becomes useful. It can operate in gigahertz range, making it ideal for high-frequency application. So what is a tunnel diode? A tunnel diode is a heavily doped PN junction diode. Because of its heavy doping, the depletion layer becomes extremely thin. So typically around some 10 nanometer. So due to this thin barrier, electrons can tunnel through the junction even without sufficient energy. So this is based on the quantum mechanics and not classical physics. So another important feature of this diode is something very unusual. It shows negative resistance. So let us now look into the construction. So in a tunnel diode, both the P region and N region are heavily doped. So this heavily doped reduces the width of the depletion layer significantly. So normally in a PN junction, the depletion region will be acting as a barrier. But here, since the barrier is extremely thin, electrons can directly pass through them. So this thin depletion layer is the key factor that enables tunneling. Working principle. Now let's understand about the working principle of a tunnel diode. So tunnel diode works based on the quantum tunneling. So in classical physics, electrons need enough energy to cross a barrier. But in quantum mechanics, electrons have a probability of passing through the barrier even if they don't have sufficient energy. Because of a very thin depletion region, electrons tunnel from one side to the other. So this happens even at low voltages. So this results in very fast current flow, making the device suitable for high speed operation. And mainly this happens due to the very thin depletion layer. Next, let us discuss about VI characteristics. Now comes the most important part, the VI characteristics. In normal diode, as voltage increases, the current also increases. But in tunnel diode, something unusual happens. Initially, as the voltage increases, the current increases up to a point called the peak current, which we refer it as IP as seen in the figure. So after this point, which is the peak point of IP, if you increase the voltage further, the current actually decreases, and this region is called the negative resistance region. Finally, after reaching the valley current, which we refer it as IV, the current starts increasing again like a normal diode. So as we seen from the figure, the curve has three regions, which is normally increasing region, and then negative resistance region, and finally the normal diode region, right? And next let us discuss about the negative resistance. So negative resistance means When voltage increases, the current decreases, right? And this is opposite to what we normally expect. And why this is important? Because negative resistance allows for oscillations, signal amplification, and that's why tunnel diodes are widely used in RF circuits and microwave oscillators. Advantages and application. Now let's look some applications. Tunnel diodes are used in microwave oscillators, high frequency amplifiers, fast switching circuits, radar and communication systems. So the ability to operate at a high speed makes them very useful in advanced electronic systems. Finally, to summarize, tunnel diode is a heavily doped PN junction and it works on quantum tunneling. It has a very thin depletion layer and exhibits negative resistance, and it is mainly used in high frequency application. So thank you for watching. Thank you for watching.